Okay, page 98. Problem number 12 says there is a 12 kilogram bucket. And this 12 kilogram bucket is lowered vertically by a rope.
Mr. Bella?
Yes.
You have a low battery.
Okay, thanks. It should make it. It's being lowered vertically by a rope in which there is 163 newtons of tension. Okay? And the question is, what is the acceleration of the bucket? Is it up or down? Okay. Bucket's being lowered, so that means it definitely has a downward motion, displacement, and a downward velocity. There's 163 newtons on the bucket. So force equals mass times acceleration. 163 newtons equals the 12 kilograms mass of the bucket times some acceleration. 163 newtons is 163 kilograms times meters over second squared. Divided by 12 kilograms will give me an acceleration. What acceleration does that give me? They got your calculators?
13.5833.
13 point what?
58.
That's fine. 13.5833. 13.6.
3 repeating.
All right.
Yeah.
Seems to be repeating. Let's go with it. Okay, now, if the bucket were sitting still, if the bucket were just hanging still, and we told you the tension on it, what would you expect the acceleration to be?
If it was still?
Yeah, if it was absolutely still.
9.8.
9.80 meters per second squared, because when you're dealing with weight, you always have that gravity to deal with, okay? So I would expect this to be 9.8. What would increase the, what would cause an increase in the tension of the rope? What is the acceleration on this bucket right at this moment we're talking about?
You have the 12 kilograms.
Pardon?
You have the... I don't know.
Well, hold that thought. The rope is behaving as if the bucket were accelerating at 13.6 meters per second squared. If the rope were hanging still, it should be accelerating at 9.8 meters per second squared. First off, let me ask the obvious question. What's the difference between 13.6 and 9.8? Literally mathematically, what's the difference between 13.6 meters per second squared?
3.78. 3 repeating.
3.78 repeating meters per second squared. This rope is feeling more acceleration, as which, since there's a mass involved, means this rope is feeling more weight than it should. If it's feeling more weight than it should, is this acceleration up or down? When the elevator is accelerating upward, I'm getting some upward arrows, you feel more weight, right? The elevator is accelerating downward. So this thing has a downward velocity, but because this is not gravity, because we did not get an answer of 9.80, we got an answer of 13.6, that means more weight is on the rope. That means this thing has an upward acceleration of 3.78 meters per second squared. How can it have a downward velocity and an upward acceleration?
Slowing down.
It's slowing down. Somebody has lowered this rope, but they've just started to pull on it to change it so that it's no longer going down. It's slowing down in its downward direction. Does that make sense? Robbie, I think you said it better than I did. Actually, it's slowing down. That's all you need to say. So the velocity's this way, the acceleration's this way, and that's increasing the tension on the rope. Does that make sense? The rope's behaving as if gravity were 13.6 meters per second squared. This way, the rope is behaving as if gravity is, as if it has to fight all of this much when gravity should only be the 9.8 part of it. We'll do free body diagrams later. I haven't introduced those. I'm trying to jump to it. I don't want to yet. You guys get that? It's being lowered, but it has an upward acceleration. And that's what is, because if you were lowering it faster, like the guy sliding down the rope, you should have less tension while it's falling. Not really falling, being lowered faster. Any questions on this one? Going once, going twice. All right, Robbie, go ahead and stop that one.